Hey guys, welcome to another video about our Docker course, and this is Daniel Pinheiro from danielpm1982.com. So in this last video about our official content for this course, after we saw everything we should know about the bridge network, both in theory as in practice, we can now get back to our main application or our main image, our meeting app Spring Boot application integrated with the MySQL image, so that now I can show you some differences when running that image, not only the first version of it, as we've already saw, but the second one. So if we go here to dockerhub and look for my profile or the namespace of my profile, you find this repository, meeting app, as we've already done a lot of times. And here I have concluded a thoroughly documentation about how you can use this image for pulling it locally and creating the corresponding containers and running those containers for accessing the application in multiple containers, the Spring Boot application in one container, accessing the MySQL application or the database for this web application inside another container. So firstly, the first version of this meeting app application actually was a standalone image. So at that time, we had not yet integrated that with MySQL. We were using an in-memory DBMS, which is actually the default DBMS for Spring Boot. It's an in-memory database just for development, and that we start testing at this in-memory database, and later we extend that by integrating the application with real databases. So that's what we've done here. The first version of this meeting app application was an standalone application with no integration with MySQL that used an in-memory DBMS called H2. So here you have the first version of the application. If you click on it, it goes to the Docker file, which is the image itself that we download locally if we want to create the containers for it. And here you have the sources, which is the code which we've containerized into this Docker file. So if you click here at the source, not at the Docker file, but at the source, you go to my GitHub profile where you have available the whole project, the whole Spring Boot project, including, for example, the application.property file that configures the connection between the Spring Boot application, which is this whole project here, with, in this case here, the in-memory H2 database. And as you remember, we have also another branch here called mysql-db instead of the master one. The master is for version 1 and the mysql-db is for version 2. So we've already used this version 2 already when we saw the integration between the Spring Boot application with the MySQL database and the synchronization between them using links. And from that version 2 to this actual version 2, I've only changed a little bit here the application.properties file in order to parameterize better here the configurations for the connection between this Spring Boot application and the MySQL database by using environment variables for all the configuration data we need for connecting this web application with the database, both running in their respective containers. So here at the data source.url, we use an environment variable called mysql _port _3306 TCP _address. We also use for the port this other environment variable here, mysql _port _3306 TCP _port. And finally, we use this other environment variable here, mysql _env _mysql _database. So these three environment variables are used here at the Spring Boot application, and specifically at this application.properties file from inside the Spring Boot application called data source.url to set the URL from this web application to the MySQL database. And also we have here the username and password that I have already changed here for receiving a value through an environment variable called mysql _env _mysql _user, as well as the password in order to receive the value for the password which the application should use to connect to the database by using this environment variable here, mysql _env _mysql _password. So we have basically here 1, 2, 3, 4, and 5 environment variables that we use to parameterize these values, so that as a best practice we do not have to fix any value as a constant, but we may receive whatever value the user passes when running the container through these environment variables. So when the Spring Boot container is set to run, the user must pass values for each of these environment variables, and here inside the application which is running inside the container, here the application takes the values through these environment variables and applies here at the application.properties file, or it could apply in any part of the application. In our case here, we are using to configure the communication between the application, the web application, and the BMS, but we could use the values of any environment variables anywhere at the code. But in this case, we're using to simply connect the application with the MySQL database. So, and if you see here, we also have let some default values in case the user forgets to pass the values for these environment variables, and in that case it will default to these default values here. In the case of the address, it will default to localhost, and as we know, it won't run because there's no container called localhost, and as we've seen, when running multiple containers and when one container is going to access another container, it gotta use here at the data source.url either the IP or the DNS of the other container it's trying to connect. So there's no container called localhost, so even if it defaults here to the localhost value, it won't, the application won't be able to connect to the database. Actually, it would be better here to have set the name of the MySQL container, a default name for the MySQL container, but also it would depend when you start the MySQL container that you would have set the same name there so that it would match the default name here. So despite that, the other default values, for example here for the port will generally be 3306, which is the main and default port for accessing MySQL databases, and the name of the database here, we've set the default name to be meeting_app_db, meeting_app_db. So just to show you that you have this option to set the receiving of a value through an environment variable inside that container where this application runs. So the application will take the environment variable and take out the value from it, and will substitute here the environment variable for the respective value that you set when you run the container. Or you can also put here after the column on the right side of the variable name a default value in case the user forgets to declare, or if he doesn't pass any value for that environment variable. So it will default in that case to the default value here on the right after the column. Also here, if the user does not pass this name for the username environment variable, it will default to this default value here, the NPM 1982 _user, and the password also, if the user does not declare this exact same name variable for the password and a value for the password, it will default to the admin value. So simply here we are parameterizing all the values we need for connecting our Spring Boot application to the MySQL database by using Docker environment variables, which are expected to be set on the running of this container that includes the Spring Boot application. So basically this is the difference between the first version and the second version of the meeting app application. Basically the kind of DBMS we're using here on the first version, the H2 DBMS, and here the second version, the MySQL DBMS. So, and for this first version of this meeting app image or application, there's nothing much to be added regarding the running of the container or the running statement of the container. That's what we're going to talk a lot during this lecture, how you can run these two versions and what's the best way to optimize the running statement for running either of these two versions of this meeting app Docker image. So for the first version, there's not much to be said other than what we have already discussed so far. And basically, as it's a standalone image, it doesn't depend on any other image. You simply use sudo docker run -it-p the port, which is going to be published for the container to be accessed from outside, from your internet browser, for example. Then we have the complete path for the application at hub.docker.conf, which is the namespace for the profile or for the account of the repository, slash the name of the repository, which is the name of the image itself, colon the version, in this case version 1 of that repository or of that image. So for running this first version, we simply use this line here at the console, and then we may test at the browser by using localhost colon 8080 /. And that's it. So very simple here. The first version, we have already saw that. What I want to show you in this lecture is, for example, a better way you can use to run this second version of the meeting app application. Last lecture we used this meeting app application. We have already executed this option on here. which is a first option for running the version 2 of this image. But actually, the way we did and the way I also document here on purpose is not the optimized way for running this second version of this image. And now we will discuss a lot more about why that's not the ideal way of running it. We saw that it worked fine, but it gave us too much unnecessary work for running the second version of this image. So in this lecture I'll show you a better way for leveraging all we saw about networks to take advantage of links features, so that we don't have to do all this for running this version of the MediNap application. But just to remind you here what we've done last time we used this image. So first we created the MySQL container from this version 2 of the MediNap application by using sudo docker run the name of the MySQL container, MediNap MySQL container. We published the two ports used by MySQL, 3306 and 33060, and we map it to same name outside ports, so that any application, for example, MySQL workbench, could access this database inside the MySQL DBMS from outside. Then we map the volume here from the inside volume, which is -var -lib -mysql, to an outside volume, which you can set here whatever local path you want in your machine. In my case, I've been using for this path here /home/daniel/temp/mysql-data. But you can use, of course, any other path you want in your local machine to map the MySQL configurations from inside this container to an outside volume path. And as we saw, you can this way save everything from your database at this external path, so that we can erase or remove anytime we want the containers and later restore the data to new containers from the same image by simply mapping back what we have saved outside the container to the container inside configuration path. So, and the only environment variable we've used here, which is the minimum number of variables here that the image itself demands, was the MySQL _root _password. And for that we've been using the value root, but of course you could also use any value you wanted for accessing as root any database at this MySQL instance. Then the -g for running this container in the detached mode, and finally here the image name MySQL colon the version 8. So here why haven't we used the namespace for my account, for example? Because this image MySQL is not from my account, it's not my image, it's a standard MySQL image saved at dockerhub. And for official images you don't have to use the namespace for any account. You simply use here the repository name, which is MySQL, and if you want also the version, differently from when you access here your own images. For example, this MediNap image is an image I have created and uploaded to my namespace account DanielPM1982. So here when we try to access this image, we have not only to pass to the run statement the meeting app name, but also the namespace of the account into which I have uploaded this meeting app Docker image, but not here when using official images, because official images will be found automatically inside anywhere at dockerhub. So for this first option, which is not the optimized option for running this second version of the meeting app application, we start the container for the MySQL database using only this one environment variable, the root password variable. Observe that we are not passing here the database name nor the username or password. So all that we do getting into the MySQL container after starting it, and then we create the database manually and we set a name for it. We create the user and we also set a name for it, and we create the password for that user. Also everything manually here by accessing through the exec command the meeting app MySQL container. Here we also set the privileges for this user for accessing this database. Initially, at least, the privileges, they gotta be all granted, even though after the first running of the Springboot application, when the database schema is completely set and all tables created, we then can restrict later the privileges, but we could also let it as all privileges conceived for this user. It won't matter, especially in this example case. We created the MySQL container, we got into the MySQL container, and we manually set the database name, the username, and the password for that username. And now the third step here at this option 1 flow is to run the Spring Boot container by using sudo docker run the name of the Spring Boot container, which can be this one. If you change that, just be certain that anywhere else where it's used, you also change for the same name, but you can change it. You don't have to use this exact container name. Then we create a link from this Spring Boot container to the MySQL container, as we want to connect the Spring Boot web application to the MySQL database we have just created and set here. And for that, one of the ways we've seen so far is by creating a link between this container and the MySQL container. And here we set the alias name for the link connection. So the link here will have as recipient this container, the Spring Boot container, and will have as source this container here, meeting app MySQL container, and as alias for that connection or link, it will have this value here, MySQL, or you could set here any other name as well, but just remember that this alias will be used to create all the automatic variables, environment variables, according to what we've seen regarding links. So if you change here, all the variables names will be changed. And in our case, as we are using those environment variables at the Spring Boot application.properties file, you would also have to change all those there at application.properties file if you wanted to reuse them at the configuration file or anywhere inside the application. So at first, at least, don't change this alias. Leave it here because Otherwise, you would have to change the whole application and Dockerize it again, and it would give you some sort of unnecessary work. And it's not the case here. What we want is simply to improve this set of running statements here from option 1, so that we have less work in running this version, which also, if you pay attention here, it uses the default bridge network. Why? Because we are setting the link and we are not setting any specific network. So the network it will use will be the default bridge network. So in short, what we are doing here at this first option is to start a MySQL container, getting into that container for setting the database username and password, and here creating a link between that springboot container and the MySQL container, naming that link as MySQL, and all this using the default bridge network, which is one thing that I had not mentioned when we last used this approach for connecting the Spring Boot container to the MySQL container, because we had not yet even mentioned about the network Docker object. So now that we know everything about the Docker bridge network, I can now say that the kind of network we are using here when setting the link is the default bridge network. And why is that so important? Because you know that at the default bridge network, when we use the link flag here or the link parameter, setting a connection between one container and another container in that same default bridge network, we have what? We have automatic creation of environment variables based on the alias for the link connection and the data from the source container, which is the MySQL container, being set those data in environment variables automatically created at the recipient container. So some variables will be created automatically here at our Spring Boot container, taking as values some data from our source container here, because we are using the default bridge network and we are setting a link between those two containers. So we saw it extensively in the last two lectures, including the patterns for the creation of the name of those automatic created environment variables here at the recipient container, and the dynamic discovery of those values for these environment variables from the source container to the recipient container, so that you would have here at the recipient container all those environment variables with the updated values from the corresponding data from the source. And now I can tell you actually why you should not do the running of this version 2 of the meeting application using this option 1 or using this 3-step flow here. And actually I discuss it thoroughly here at this observation, but in short, this option 1 is not the best optimization for running this image. Well, first of all, here at the MySQL container, we should not publish the port if we didn't need external applications to access the database inside this MySQL container. And in this case of our example, we won't need it because the other container will have access to all ports declared at the source container without anyone having to be published. So the only reason why we would eventually publish these ports from the MySQL DBMS at the MySQL container would be in case an external application would have to access this MySQL container, for example, the MySQL workbench. If we want to use it, then we would still have to publish this port, even knowing that for the Spring Boot container that wouldn't be necessary because the two containers are both running in the same network, and thus all ports from one to another and vice versa will all be available without we having to use the -p here from publish. We only need to publish any port when that port is going to be used from an outside application. For example, here at the third step, we have to publish the Spring Boot container port 8080, mapping from the internal port 8080 to the external port 8080, because our browser wouldn't have access to the Spring Boot application inside this container if that port 8080 wasn't published. But here at the MySQL container, we have no external application accessing the database. The database will be accessed only from the other container running the same network and thus having access to all ports. So this publishing here is unnecessary, is actually not desired, because you end up exposing the database to external attacks, for example, from malicious softwares from outside the containers, because they will have these ports here, and depending on the implemented security inside the DBMS, that an eventual hack attack, for example, could be perpetrated by using these published ports. So, including for security reasons, we shouldn't publish unnecessary ports unless inevitably necessary. For example, if we have to access from an external application, the application running inside the container. So, and not only that, but also here regarding the environment variables, here at the MySQL container, we only set here one single environment variable, which is the root password variable. But instead of having later to get into this first container, the MySQL container, for creating, for example, the database name, or actually the database itself, for setting also the username and the password, we could add some more environment variables here at the run statement itself, creating already at once here at the same run statement both the database and setting the database name as well as the username and password. So at the MySQL image, there's a feature that if you pass here not only the root password but also some other environment variables, then MySQL will automatically use the values from that standard environment variables to create not only the database but also the username and password at once here, without further effort or further work of getting into and creating those manually. So instead of all this we've done here, we could simply have added 3 more environment variables here at the run statement, and the database would have been created, the username and the password as well. So we'll be doing that on the option 2 right below here. I'll later show you how to do it right. Firstly, I'm showing how to not do it right, but then here below I'll show you the way how it should have been done. But let me also show you why this option 1 is not optimized also for the run statement of the Spring Boot container here. So here at the Spring Boot container, we have already mentioned here the creation of the link, and that both containers are being created automatically at the default bridge network. So all the features from links when used inside the default bridge network will be available here, including the automatic creation of environment variables following the name patterns we already saw, as well as the dynamic discovery of the values from the source to the recipient. These will all be available here, so we kind of end up being redundant in case, for example, we have set those environment variables here at the source, and those values had been, for example, reused here to set the corresponding automatic created environment variables here at the recipient, and we shouldn't, for example, be redeclaring or recreating those variables explicitly, because they will be already implicitly created and also implicitly set from the data here from the source to the recipient. But here, as we have not even used the environment variables here at the source, for example, the MySQL database, the MySQL user, and the MySQL password, these three environment variables at least wouldn't have been created at the recipient because they would not have been declared at the source. So inevitably we would end up having to explicitly declare some of these variables here for the database, the username, and the password, even when using the link with the default bridge network. But for example, the address environment variable and the port, at least them two, wouldn't need to be declared here at the recipient because they are automatically created from the source data. This source has the value for the address of the MySQL container, which is its IP. So when you create here the link, an automatic generated environment variable here at the recipient is created for the address using the MySQL alias of the link. So MySQL underline port underline 3306 underline CP underline address would have already been created here at the recipient with the IP, not with the DNS, but with the IP from the source container, in this case the MySQL container. But even to prove that we have here the DNS resolution, I have not only redundantly declared this environment variable for the address, but I have changed from the IP to the DNS name of the first container or the MySQL container, which is the name of the container, Midinap MySQL container. And also for the port is declared even if we didn't publish those ports here. These ports are declared at the Docker file of this first container, so when creating the link, an environment variable is automatically created here at the recipient using the MySQL alias, underline port, underline the ports that are published either at the Docker file or here explicitly at the run statement, but in our case, for example, at the Docker file, MySQL underline port underline 3306 underline CP underline port, and the port 3306, which is the main port used here to connect these two containers, the springboot container to the MySQL container. So at least these two environment variables, even in our specific case here, are completely redundant, and the other three would be redundant also, but only in case we had declared them at the source container, which is what we're going to do in the optimize second option for creating the container for this Midinap version 2 image. So instead of you follow this option 1, which is what we did last time we used this image, you can simply, after reading all the observations that I have written here and that we have just discussed, you can jump here to option 2 and use instead this other optimized flow for running this version 2 image. So in what we do here at option 2, we simply create and start the MySQL container by using sudo docker run the name for the MySQL container, meeting-app-mysql-container, the mapping of the volume through -v. Here you set any local path at your machine for mapping from the internal volume of the MySQL image. And importantly here, you also do not publish any ports. We don't need that. And regarding the environment variables here, you declare and set not only the root password, but also at the same run statement, you also declare the database with the name of the database you want to create, the MySQL user environment variable with the value or the name of the username you want, and also the MySQL underline password with the value for the password you want to set for the database you're creating here inside this MySQL container. Then -d for running the container at the detached mode, and finally the MySQL image name, column, the version, which is version 8. So what optimizations we have done here? We have excluded the publishing of the ports. Instead of publishing these two ports that we won't need, because we won't have any external applications trying to access this database, and the only application which will have to access this database here is the Spring Boot application, which is in the same network. So we won't need this publishing because all ports will be exposed to all other containers or application inside any other container running the same default bridge network in this case. And also, instead of only one environment variables, we are already passing at the run statement these other three environment variables, which are the MySQL database, the MySQL user, and the MySQL password, so that the DBMS can automatically create all this we have done here manually, which is the database, the username, and the password. So we won't need to get into the MySQL container to create it manually, because it will be already created by MySQL if we set these specific variables, the MySQL database, the MySQL user, and the MySQL password here at the run statement of the MySQL container. So these are the optimizations regarding the MySQL container, and what have been the optimizations for the Spring Boot container. Well, basically we simply have leveraged the link properties, so that in this case here, as we have all the variables here at the source being declared and set, those values will be mapped and copied to the recipient container, and the respective environment variables will be automatically created, and these values automatically set or discovered from the source to the recipient, and the names created according to the patterns we already saw, taking the alias as the initial part of each name, so that we won't have actually to declare or set any environment variables explicitly here at the recipient, because all necessary variables will be automatically created by Docker, because we are using links in a default bridge network. So Docker will take all these variables here and create the respective variables at the recipient container. And of course, as those variables are created and set, they can be used by our application. For example, at our Spring Boot application, specifically at the application.properties file. If we go here at the second branch here, mysql-db, which is the branch for the second version of this meeting app application, and you go here at source main, resources, and open up the application.properties, you can easily see that all the automatic created environment variables are being used here at application.properties file of the application to set the properties we need for the connection, including the user and the password, as well as the database name. And here, for example, the address environment variable, we reset from the IP to the DNS, so the DNS will be used here, the DNS for the MySQL container, and it will be automatically resolved to the IP again, simply to prove that we still have DNS resolution here because of links. If we wouldn't be using links, remember that we wouldn't have the DNS resolution at the default bridge network. So all those environment variables, even if we do not declare at the run statement, they will be automatically created because of the link we are using, and it will be used inside the application at the application.properties file. So these basically are the improvements we've done for correcting all these issues we had here when compared the option 1 to the option 2 flow of running statements or running steps. So instead of this option 1, you simply use this option 2 set of steps, which are much simpler than the steps from the option 1 flow. Okay, and now let's change a little bit again the running statements for using not default bridge networks anymore, but user-defined bridge networks. And similarly to other two cases before, we'll be showing you a not optimized flow option 1 here, which is not the way you should do. And then we discuss the limitations for this flow, and later we correct everything in this option 2 here. So for running Midnap version 2 using not default bridge networks but user-defined bridge networks, as we saw before with other examples, first we gotta create the network itself. So if we follow here the option 1, we first use sudo docker network create the driver bridge, as we are creating a user-defined bridge network and the name of the network you want. For example, bridge -DanielPM 1982 or whatever name you want. So firstly, we create the user-defined bridge network, and then we proceed with the running statements of the MySQL container, similar to the other cases, but using sudo docker run the name of the MySQL container. Here we set specifically the network we want instead of not setting it, because we have already seen that if we do not set the network that's going to be used is the default one, and we do not want to use the default but this user-defined bridge network which we have just created here above. So we gotta set here the network flag or parameter, and on the right we gotta set as value the same name of the user-defined bridge network we've just created here right above, so that this container will be run using this user-defined bridge network. So, and then all the rest is the same, the mapping of the volume and the creation and set of the needed environment variables for the MySQL DBMS to have a root password, create a database, create a username, and create a password for that database. And then -g for running the container in the detached mode, along with the MySQL image name column 8. So basically the difference here at the MySQL container running statement is simply the setting of the network as the user-defined bridge network instead of the default bridge one. And finally here, at the running statement of the Spring Boot container, we also gotta set the network, not for it to use the default one, but the user-defined one we just created above, the same way as with the MySQL container here. Then we publish the 8080 port. Why? Not because of the MySQL container or the Spring Boot container, but because of the browser that is an external application that's going to use through the 8080 port the application running inside here the Spring Boot container. So we still have to publish this 8080 port from the Spring Boot container so that the browser can access the Spring Boot application running inside. Otherwise, no external application would be able to access it. And then the environment variables. Have in mind that we are not using links anymore, so we won't have the automatic generated environment variables anymore. So we gotta set each one of those environment variables here manually at the Spring Boot container, because the Spring Boot container now is not a recipient for the MySQL container. So we gotta set these values manually. The address, which can be the IP or the DNS for the MySQL container, the port, environment variable, the database, environment variable, the username, and the password. And we actually wouldn't need to use exactly the same name that I've used here, but for me not to have to change the application.properties file again to a third version, I simply reuse the same pattern here for the names of these variables, exactly the same as we had created automatically when using links on the other cases. So only for not having to change the application and re-dockerize it and publish again to a third version at dockerhub, I simply kept here the same names, even that in this case we're setting it manually and not with automatic generation anymore. So the address, the port 3306, the database name, the username, and the password. So these variables will be used inside the same way at the application.properties file, and their values will be used to set the connection inside the Spring Boot application. And then the -g for running it in the detached mode, and then the name of the image along with its version 2. So basically the difference here is that we can no longer depend on automatic generated variables because we do not have links anymore. So when using user-defined bridge network, remember that we do not have any automatic generation of environment variables at recipients because we do not have a link anymore from the source to a recipient. They are both independent containers now. And we also set here the network to the user-defined bridge network we want to run those two containers at. So basically these are the differences when using this first option here of run statements for adapting the running of this image to user-defined bridge networks. And here I give some details about everything we just discussed regarding that. And finally here, as a last option, I suggest the best way I have found so far to run this version 2 image of the meeting app application, which is by simply using a YAML file for the Docker Compose, which will start based on that YAML file the image of the meeting app application version 2 as soon as we use this single command line here, sudo docker compose app. So observe how simpler it can be if we use a YAML file, which, for example, the user of the image may even not pay attention what's inside the YAML file. He simply has to have that YAML file anywhere in his computer. So, for example, you can download this YAML file here or copy its content to a local text file with the YAML extension here, and using this name docker-compose, and then you simply have to go to the directory where you have put that YAML file and use this docker compose command, sudo docker compose app. And with that, docker compose will start that version 2 Mirinet Spring Boot image based on the configurations we will have inside the docker compose.yaml. So this is the first time we'll be using docker compose instead of docker commands. Docker compose is not a docker command, it's a separate application which you have to have installed so that you can use it, for example, for calling sudo docker compose app, the app command, or the down command. And here at the YAML file, if we click on it, we simply create some services. In this case, a service called app, where we put all the properties for running that service from the Docker Compose application, and a MySQL service for running the MySQL container by using the Docker Compose directed to this YAML file here. So at the YAML file, basically we'll create and define and set all the properties for running each service being each container will be creating and running from a specific image. So I'll get to it again in a minute, but basically at option 2, what you gotta do for not having, for example, to manually declare all these environment variables here each time you want to run the containers, neither the MySQL running statements nor the Spring Boot running statement. You simply create a YAML file with the running properties for both containers, or in this case for services for those two containers, and you simply call sudo docker compose app. So when using docker compose, we do not run any statement for running images or for creating containers and starting those containers. We simply use docker compose and the single command app. So docker compose will take all the information inside the YAML file, and without us having to repeat each time we wanna create and start the containers, it will take those information and run, and the only thing we gotta type at the console will be docker compose app and or docker compose down. So you see that it's incredibly easier to work with docker compose and YAML files, and that's why almost all applications nowadays use docker compose and YAML files for creating and starting any number of containers. You can create at the YAML file any number of containers you want. Here we created only 2, but for example we could have set the properties for starting at once 20 services or 20 containers, and still we would have only one YAML file and only one CLI running statement, which will be the docker compose app command. no matter how complex the YAML file will be inside. But for the final user, for example, he would not have to pay attention what's inside the YAML file. He only would have to have that YAML file from the developer and call this sudo docker compose app command. So basically, this is it. 4 ways of running, actually 5 with the version 1, but for version 2, for example, we have here 4 ways of running. The first 2 using the default bridge network, and the first option flow that we would not use, and the second one that we should use when using links and default bridge networks, as well as for the user-defined bridge network, also a first option flow we should not use, and a second one we should use when using a user-defined bridge network. As we're going to see, always Docker Compose will create user-defined bridge network for running the containers whose properties will be set inside the Docker Compose.yaml. So for using user-defined bridge network, always try to use Docker Compose and create one single time the YAML file, which can be reused how many times you want by simply calling docker compose and the app command. Okay, so now let's get to the YAML file and see details about how to create it. So before we get to our console, let me just explain a little bit more for you about what a YAML file is, what the YAML language is, and later let me show you where to find the documentation for Docker Compose and all the specification for it, so that you can specialize on that if you want. And then we'll get to the console and we start practicing all we're talking here regarding these 5 ways of running the meeting app application. Just have in mind that this last way of using this image is actually the way you should use it, because it's the best optimization we can do by creating our YAML files for Docker Compose to execute, and through that we turn out with this very simple and single command line here for using at the console. So first, what actually is an YAML file, or YML, or YAML file? You can go here to this URL yaml.org, and here you will find all the official documentation for this serialization language, which is actually simply a way of representing scripting and programming data in a human-friendly way, which can be serialized and deserialized using YAML engines. So for many of the programming languages and script languages we have, there are engines or programs that can serialize from that language to YAML, and later from YAML to the same or to another scripting or programming language again. So, and why is that important? Well, basically because through that you can create an agnostic representation for your important data or data that you want to share through different computers, in this case here through different Docker containers. So instead of representing that data through any script and programming language, you couldn't do that while transferring that through the internet. So you should have a way of representing that data in another language which could be serialized and deserialized from and to each of these languages here. For example, from JavaScript, from Java, from C, from Python, and so on. And the data of, for example, of a certain object at that language could be represented at this serialization language, for example, YAML, and then deserialized when it gets to a certain destination, for example, in another computer or in another system, and so on. So there's a couple of languages you can use to do that. For example, I guess the oldest one, which is actually still very useful, is XML. So through XML you can represent and transport data from one source to a certain destination, and you can serialize that data, for example, from a Java object to an XML file, and then transfer that to another computer, maybe running another programming language, where through a deserialization engine or program, you could deserialize that XML data from the XML file to, for example, another object at that other language. We could have a first computer running Java, the destination computer running PHP or Node.js with JavaScript and so on, but the XML file would represent the same way that data that we would like to share from one place to another, from a source to a destiny computer or system or so on. So these languages for representing data have acquired a very important job in transmitting that data between different places or between different systems. And another very useful application is to write configuration files using those languages as XML, JSON, and in this case also YAML. So here we have the most recent publication or version of YAML language, which is the revision 1.2.2 from October 1st, 2021. And you can click here and you have specifications for that version of the YAML language. You can read it all if you want. Be my guest. It's not so simple as it would appear. So I'll let for you to take a look if you want. Or you could also search for YAML in any search engine and have a look, for example, in some shorter descriptions of it. For example, here at Red Hat, there's a much shorter explanation about what YAML is, about the YAML syntax, only the basic elements, some examples, why it is used for. For example, it's used for Kubernetes, resources, and deployments. Also, in our case, we know that it's used for Docker Compose in order to represent all the layers of command that Docker Compose will execute. And for example, it's also used for configuration files at Spring and Springboot. So instead of the application.properties file, for example, you could have an application.yaml with all the configurations for our Spring Boot application inside our Spring Boot container, and that would work the same way, because the Spring would have this engine to deserialize the configuration information inside the YAML file to the Java language, which is the language that Spring uses to do all the configuration of the projects we create with this framework, and so on. So basically, YAML serves as an easy and human-friendly data serialization language for all programming languages, including, for example, Java, or JavaScript, or Python, or PHP, or C#, C++, C, and so on. And it's useful both for representing data that's going to be transferred from one system to another, and also to create configuration files with any orientation necessary for each system that uses it to run. So you can read more about YAML. You can create, for example, sample YAML files and try that. But we'll focus now on simply how to create basic YAML files to make our Docker Compose work and create our Docker containers from our sample Docker images. So, and now, before I'll explain to you the Docker Compose YAML file here, let me just show you the Docker Compose documentation at the docker.com docs section. For example, if you go here to the Docker docs main page, and you click here get started, you can go here to part 8 of the get started, and you have there an easy to read explanation about Docker Compose, which is the one I used to create our YAML file, and it shows you the very basics of Docker Compose and Docker Compose properties, which you can create inside your YAML file, your Docker Compose YAML file, in order to turn that YAML file readable by the Docker Compose service or program. So what is Docker Compose? Docker Compose is a tool that was developed to help define and share multi-container applications. And we'll see how much easier it is to define. For example, if you have 10 containers that you should create and start from different images, how much easier it is to simply create this YAML file with one service at that YAML file for each container you want to create, than if you would have to use the docker run command for each one of those containers. With Compose, we can create a YAML file to define the services, and with a single command. What is the single command? Docker Compose app. So with this single command, Docker Compose app, we can spin everything up and tear it all down. For example, with the Docker Compose down command. So we can use simply two commands for Docker Compose, which are Docker Compose app for starting everything up, and after, when we want to shut down all the containers, we simply use Docker Compose down, and it will close all of them. So basically, Docker Compose serves for that. And the big advantage of using Docker Compose is you can define your application stack in one single file, which is our YAML file, and keep it, for example, at the root of your project repo, for example, at your GitHub or at your local project. And then anyone that have access to that single file, that single YAML file, can simply start the whole application without having to understand any dependencies or running conditions or parameters or anything regarding the running of the system, by simply using Docker Compose app, and that will start all the layers of the application simply running that YAML file turned available to that final user. So it's much simpler for the final user to use Docker Compose and simply have that YAML file turned available to him or to her from the developer team. And of course, the developers would need to know how to create the YAML file and all the commands that should be translated to a YAML file from the docker run commands to a YAML file, which is what we're going to show you now, as the intent of this course is for instructing developers and not simply Docker final users that would not have to know much about this technology. So we as developers, we should learn a lot more so that we could, for example, create our YAML files for the whole system we are Dockerizing and turn that available to the final users or for the testing teams and so on. So here it also tells you how to install Docker Compose. Maybe for your installation of Docker, you will already have Docker Compose installed. You can simply use, for example, Docker Compose version, and if you have any result for that, it means that you already have this software installed. Otherwise, you would have to look by using apt or snap or any other installation program how to install that, which is as simple as installing Docker. Actually, it's even simpler. Then the documentation here starts telling us how to create the YAML file. For each container, we are going to create a service. And here, importantly, it shows the relation or how to take a Docker run command and for each part of it or for each layer of it, translate those Docker commands to a YAML file. So to be even clearer, what we'll be doing for using YAML files and for using Docker Compose is simply to stop using Docker run commands. Remember that for each container we created and started from a Docker image, we were using a Docker run statement, and now we won't be doing this anymore. We don't have to use Docker run commands anymore. Why? Because all the commands and properties and environments we should declare here, not only the variables themselves but the values for those, we will be setting at our YAML file. So we'll translate everything that we had at our run statements to a single YAML file, which will contain not only one run statement translated to a service, but multiple services, being each service a translation of one run statement. We would have to run or to type in the console for running one specific container. So if we have 10 run statements, we can simply translate all those 10 run statements to a single YAML file, and for each run statement we would have here at the YAML file one service. So basically we use the services mapping. This is a mapping. Every time that we have a column at a YAML file, that means a mapping. This is the key of the mapping, and all that's on the right is the value. For example, this is a mapping of another mapping of another mapping of the value node column 18-open image. So the YAML file basically is created using mappings and lists. We have not the list here, but we'll have soon enough right below. So we start creating the services mapping and setting the services here below. For each container, we create a service In this example, for the web application, it's creating here the app service. Inside each service, we set other properties, for example, the image property here, indicating the image name and version of the application, the Docker image we are creating the container from. We can also set, for example, a command for when having that container created and started, we could automatically call any shell command after that. For example, the env command or the exec command or any shell command or any CLI command from Linux or from Docker. We can also set the ports. Have in mind that what makes these properties here belonging to this service is the indentation. And for example, YAML doesn't work with tab indentation. So for indentations, you will always use spaces between this app service and all these other properties here inside. We have two spaces, 1 and 2. And for example, between a key and a column and the value of the mapping, we have 1 space. Here at lists, this is a list, an hyphen or a dash with a space. This is a list. We can have multiple items at that list, but for each item you would have an hyphen or a dash plus a space, one single space. So it's very important for you to, when using YAML or writing YAML files, to take very careful about the number of spaces you create, because one space can make the whole difference and break your configuration here. So spaces are taken very seriously by YAML engines. So you gotta use the right number of spaces either for the indentation as for the basic structures you have, the mappings, the lists, and so on. So here we're creating the app service, defining the image, the command, the ports. Here we have only one single mapping of port, mapping the internal 3000 port for the external 3000 port at the system, from inside the container to outside at the system. We can also set the working dir. In our case, the working dir is already set at the Docker file, so we don't have to do that. We can also set the volumes. Also, you can set here the environment variables with the environment property or key for the mapping of all the variables you want. And here below, all the mappings for each environment variable, the environment variable name, and the values here on the right. So it's pretty simple to use the basics of YAML. If you ever used JSON, you can see that it's very similar to JSON, although we have some differences, but YAML actually is a superset of JSON, of the JSON language, which is also a data representational language, which is serializable and deserializable by using some engines for each programming language. So this is the creation of the app service, where it defines the image name, the command that should be run after the container is created, the ports mapping from inside to outside the container, the working directory, the volume map for that app application, and the environment variables for that web app container. And here down below, it shows another running statement, in this case here for the MySQL container, which it also translates here to a second service of the YAML file. First, it defined the web app YAML content and properties, and then now it starts defining the second service of that YAML file. It will be run by the Docker Compose, and at that MySQL service, let me go here to the last part of it. You can see that for this second service, which is the service MySQL, that will be used by Docker Compose to create the MySQL container and run it. You have also the image, the volumes, and here very similarly to what we've been doing so far, for example, mapping the internal MySQL container volume to an external volume, local volume at the machine. We've been using this a lot and will be used in our case that so the volumes and here the environment variables similarly to the other servers, the app service here on top. So here we have two services defined for this YAML file, which will be used by Docker Compose to create two containers. One container for the app application and another container for the MySQL application or the BMS, integrating those for communicating between them when using Docker Compose. So we'll do something very similar in our example, and down here below, after you create the YAML file, you simply call Docker Compose app. You can use the -g for making it run as a daemon service on the background, and when you want to turn it all down, you simply call Docker Compose down. And then when you do that, it will close or terminate all the containers it has started before. And you can also set a sequence for that. We'll do that in our example, both for the sequence for starting each service, which represents each container, and also the sequence, on the other hand, for closing them down, each container down. So this is the basic documentation we have at this get started section. Use Docker Compose, but you also, other than this, you also have this another Docker documentation, docs.docker.com/compose, which is a much detailed menu about how to use Docker Compose. You have a lot of other more specific configurations you may use for representing our YAML file and for running Docker Compose itself. And also we have a third documentation about it, which is actually the specification, the complete specification for Docker Compose. And it's, if you see here, it's the most extensive documentation. You have all the names you can use at the YAML file and that Docker Compose will be able to understand, and all the semantics for each one of them. So if you want to read it all, be my guest here also. But in our case, we'll do some simpler example. We will not be using everything about Docker Compose, as well as not all of its specification, including not everything that we could specify at the YAML file, because we simply want this YAML file for our two containers, our web app container or our springboot container, as well as our MySQL container, and make those two communicate between them. So let me just close here the documentation. Okay, so now I can show you the YAML file that we'll be using for our application, meeting up application. We have already seen a little bit about YAML itself as a data representational language, and we also saw at least where to search for the documentation of Docker Compose. And now we'll join them both for creating or explaining this YAML file I've created for running the two containers of our meeting app application, and later we'll simply call docker compose app for using this YAML file and starting those containers and tests at our console. So where you can find this YAML file, you can find that here at the documentation of the meeting app at dockerhub. I add the second option here of how to run this application using user-defined bridge networks. At the option 2, where we talk about the YAML file and the Docker Compose, you can simply click here at this YAML file and it will direct to the source of that project here at my GitHub profile, Springboot Meeting Management. The branch is the other branch, mysql.db, not the master one. The master one is for that first case we had when using Docker for the first time for this application. But now we are using this branch mysql-db, and at there you will have here a docker compose.yaml, which is the YAML file we gotta have for calling docker compose on it. And the YAML file content basically is this one. It's a very simple YAML content defining two services, one for the app container or Spring Boot container, and another for the MySQL DBMS container. So for the app, in our case here at the meeting app application, we set the image name, which we already know it's Daniel PM 1982 / meeting app version 2. We also set, and that's optional, the container name. If we do not set manually here explicitly the container name we want for the container that will be created from the service by Docker Compose, Docker Compose will create an automatic generated name for the container. For example, test, anything that would be the name for the container. But in our case, as we want to communicate from one container to another, and we will be using this name of the container as the DNS for having it accessed from the other container, I chose to explicitly set the name I wanted, which is the name we've been using so far for it, meeting app Spring Boot container. Here we also set the ports mapping for the Spring Boot container. Remember that the only mapping we have for ports is the internal 8080 port to the external 8080 port at the hosting system, so that we can access the 8080 internal port from the outside 8080 port that our browser will use to access the Spring Boot application. And here, right next, we set all the environment variables we want for that Spring Boot container, including the MySQL port 3306 TCP address, which could be the IP for the other container or the DNS for the other container. The other container name here, observe that we had to set the same way as the DNS we're using here. Then the port 3306, MySQL port 3306 TCP port, the MySQL env MySQL database, meeting appdb, the MySQL env MySQL user with the username, and the MySQL env MySQL password admin. So all this we had already used at our Docker run commands. The difference here is that we are basically mapping through the run command we had here at option 1, which I repeat is not the best optimized way of running these containers, because for each container run you would have to set everything at the run command line, so it gives chance for a lot of mistakes, especially for the final user that would have to type all of this at the command line. So instead of this, we should always use Docker Compose and create a YAML file that would be created only one time by the development team and not by the final user of that containers. And inside, we also set only once all the properties, including the environment variables here that we'll be using in the case of this Spring Boot container by the application.properties file inside that application. So I kept here, as I've already said, the basic name format that would be created if we were using links at the default bridge network, only for not having to change the application.properties file, for changing all of those environment variables names and having to recompile the project and recontainerize the project and creating a third version. So that's the single reason why I kept these names. But of course, you could set here any name you wanted for your variables, as long as those variables internally at the Spring Boot configuration file were the same. Otherwise, if you declare the variables here, either at the docker run command or at the YAML file, and inside the application, for example, at the application.properties file, you use a different environment variable name, of course, those variables names won't be available inside the container, and of course, the application will fail, for example, to connect to the database, as those variable values would be needed for the connection to occur. So remember that these variables you can use any name you want, as long as you also change at the application.properties file or anywhere else at your code where you use those variables to get access to the respective values of those variables. In our case, the database name, the username, the password, the port, and the DNS of the MySQL container. So another thing that I added here, which in the case of our example is critical, is this option here depends on telling that this service app will depend on another service, and the condition that it should observe is that that second service should be in the healthy status. So down below I'll explain what the healthy status is, but this is simply for telling Docker Compose to not proceed with the execution of this container before the other container it depends on, in this case the MySQL container, has this condition service healthy. And why is that? Because if we start the Spring Boot container before the MySQL container is started, of course we won't be able to make the connection between those two containers because the database won't be started yet. And of course everything will fail and Spring Boot will simply end with an error message the execution of our Spring Boot meeting app application. So for that not to occur, we can simply use this technique here to tell Docker Compose to not start the app service until the MySQL service is with healthy status. And down below here, we set the MySQL service similarly with the image setting, the container name for this container, the MySQL container, meeting app MySQL container, the volume mapping from the internal volume of the MySQL to a local volume at our computer, for example, home/daniel/temp/MySQL data. Here we set the environment variables, the MySQL root password, the MySQL database name, the MySQL user and the MySQL password, similarly to what we also set here at the run statement. Everything we did at the run statement, both for the Spring Boot container as for the MySQL container, we are now putting into one single YAML file that will be written only once by the development team and will not have to be repeated by the final user to avoid mistakes. But everything we had there, we are putting here inside: the image, the container name, the volumes mapping, the environment variables, and if you observe here, the condition for the health check of the MySQL container. So remember that here I said that we were setting the first container here, the web app container, to only start after the MySQL is set to the service healthy condition or status. And here down below we set what that healthy status is, so that Docker Compose can make a check at that second container, the MySQL container, and by using the CMS shell command, it will call this command here, this Linux command, mysql admin ping. And if the ping succeeds regarding the mysql admin execution command, it's because the MySQL is running. And if MySQL is running, it means this service here is running as well. So then, and only then, Docker Compose will know that it can proceed with the running of the Spring Boot container, because it will know that the MySQL service has been used to create the MySQL container, and that according to what we set below, it's now at the service healthy status. So if the MySQL container, for example, take a little bit longer to start, and the ping here results in a negative result, it will keep trying the ping check according to this interval and for this exact number of retries, so that only when the ping succeeds, then Docker Compose will end creating this first container, the Spring Boot container, and will run that Spring Boot container, which will make the connection between the web container to the MySQL container. So we'll always be certain this way that the MySQL container will already be running when the Spring Boot container tries to connect with it. So this is pretty critical for you to know how to use. It depends on and the health check when using examples like this of a web application that depends on a database application, and the web application should only be started by Docker Compose after Docker Compose can be certain that the MySQL DBMS is already running and succeeded in starting the DB. So basically this is it for our YAML file. So, and then you can simply copy this, all of this content, to a text file and rename that text file to docker-compose.yml. And there you have your YAML file for running this meeting app application by using Docker Compose, which is the best way we have and simpler way of running this application. So in here at the end of the page for this documentation, this dockerhub documentation for the meeting app repository, I simply discuss about some other restrictions and problems you may find when running any of the containers that we'll be using with this application. So if you have any doubt about any of these options for running, either using the default bridge network, we have two options for that, or when using the user-defined bridge networks. We have also two options for that. The last one being the Docker Compose way. Docker Compose will always create a user-defined bridge network automatically, and it will run any container inside that automatic created user-defined bridge network. So if you always use Docker Compose, you basically never use again default bridge networks. And for user-defined bridge networks, you should always use Docker Compose, create an YAML file, and simply call Docker Compose app for Docker Compose to take that YAML file, set of layers, and one by one for it to use to create the containers. So I guess this is it for the documentation that I wanted to show you. And now finally, let's go back to our console and execute these two options too. This first one for using default bridge networks and running the best optimized way of this meeting application. And for the defined bridge network, let's execute also the second option for showing you in practice how Docker Compose will work when using this YAML file to execute the containers. So first, let's execute this example for using the default bridge network, but in this second option here, this best optimized option, and you can simply copy. That's why I created this documentation. You can simply copy here these Docker running statements to your console and change these placeholders between square brackets here that I have let for you to customize. So here at the volume mapping, let me put /home/Daniel/temp/mysql data. So sudo docker run, the name of this MySQL container, the mapping for the volume, and environment variables, and we'll set all of the necessary variables here for not having to run into that container later for creating it manually. So we simply set it here at the run statement. The MySQL root password, I'll set it to root. The MySQL database name, I'll set it to meetingappdb. Then the MySQL username, I'll set it to DanielPM1982_user. And lastly, the MySQL password, which I'll set to admin. Remember that you can set any values for these environment variables as long as you keep the consistency, and at the second container run statement you also keep the same values for the same environment variables. So later I'll set here the -g for the detached mode when running this MySQL container, and finally the name of the image MySQL column 8. We only have to do that for creating this MySQL container using the default bridge network. So remember that when we do not use the -- network flag or parameter, always that container will be created using the default bridge network, which is what we want to do now. So enter. It will fetch the MySQL image at the dockerhub and download it. Then it will create the container and start the container. So the MySQL container now is running with the configurations we passed here at the docker run statement. Observe that here we are not using YAML files or Docker Compose. We are simply using Docker and one of the Docker commands, which is the run command, and then all the parameters here or flags that we should be used for creating and start that container by using the docker run command. So the MySQL container has been created at the default bridge network and is up and running. And how we see that? Sudo docker ps-a. So it's up and running, and it should now already be available for our second container to link and proceed with the database connection from the Spring Boot container to this MySQL container here. So now what we want is to create and start the Spring Boot container from the Midinap Spring Boot image at our dockerhub repository. So for that, also you can simply copy here from the repository documentation this docker run statement and copy here. So sudo docker run, the name of the Spring Boot container, Midinap Spring Boot container. Here, as we are using the default region network, we'll also be using the link or link flag and set as the link name the MySQL name, and as the source for this recipient container we are setting the Midinap MySQL container with the publishing of the 8080 port from inside the container to outside, the -g or detached mode, and here on the right the name of the repository. It's not an official image. Remember that when you want to run not official images or private images created by simple users as me, you should always use first the repository name slash the name of the image, in our case the Midinap image, colon the version of that image. So here also we are not setting the network. Why? Because we want to run it using the default bridge network and using our link. So also observe here that we are not setting any environment variables. Why? Because all those variables will be automatically created. We have already discussed that because of the link flag here. All these environment variables here, for example, the other container, MySQL root password, the MySQL database, the MySQL user, and MySQL password will have their values mapped to other variables here at the Spring Boot container, starting with the MySQL name. And all these automatic created variables will be automatically set dynamically at runtime from the values here that we passed for the other containers. So Docker will map all the values from the environment variables we created at the run statement of the MySQL container and create the Spring Boot container own variables, automatic generated variables, and copying those values from the source container to the recipient container variables. And those variables are the ones we'll be using at our application.properties file, as I've already shown you a lot of times before. So in short, we don't have to pass or to create any environment variables here when running the Spring Boot container, because all of the necessary variables will already have been created and the values dynamically set from the values that we passed here at the run statement of the source container. This is the source container, this is the recipient container. All these environment variables values will have already been passed here to the variables automatically created at the Spring Boot container. So let's hit enter. It will search for the Midinap image at dockerhub. It will download it and all the layers of it. Then it creates the Spring Boot container and starts it. So now if we call again sudo docker ps-a, we have two containers created and running, both the MySQL container as the Midinap Spring Boot container. And now if we try here calling localhost colon 88, we have the application running and the connection between the two containers succeeded. So for example, we can test here to add one more user to see if the database is actually working. Add. Here we have a fourth person here. And for proving that the database is working, let's just close or terminate those two containers and start them again. So sudo docker ps-a sudo docker container stop. Let's stop first the meeting app container. We are not removing it, we are simply stopping it. And now let's stop the other container, the MySQL container. We are also not removing it, although we could, because all the data for that database, remember that it is mapped to another folder and it's not restrained to the container itself. All the data necessary to recreate eventually that database is mapped to an outside folder. But let's just simply stop here and start those two containers again. Sudo container start the MySQL container and then the springboot container. Okay, those two are started. Sudo docker ps-a and they are both up and running. So let's get again to the browser and test if the persistency worked. Localhost 8080. If we click here at persons, so here it is the fourth person persisted even after we closed or shut down or stopped those two containers and started them again. Okay, so this is the best way, the most optimized way we have for leveraging the full extent of links and the best optimization for the run statement when using default bridge network. So you can read all the discussion that I put here, but please do not end up doing this. This option here is the one I'm showing you how not to use this image. So if you want to run it in a default bridge network, please use this second option here, which is pretty much simpler and more economic in terms of effort when writing the Docker run statement. Okay, so now let's go to the other part, which is how to run the same meeting application using user-defined bridge networks. And this first option I'll not even bother to use because it's also not optimized. Observe that we are creating a user-defined bridge network and running this container on it, but it gives us a lot of work to write all of this down at our console each time we want to run each one of those two containers, and even having to declare all the variables at our YAML file, for example. It's much better to do that there, to map all these two Docker run statements to our YAML file and simply call Docker compose app for running these two containers the same way. Also using user-defined bridge network, because Docker compose always creates a user-defined bridge network to run any set of containers through the services it finds in the YAML file we pass it. So instead of writing these Docker run statements, let's just go through and pass all that to the Docker compose YAML file. You can simply click here and copy all of this to a local YAML file, but first let's clear here all the objects we have. For example, the containers, sudo docker container remove -f to force the stopping and later remove. dollar open parenthesis sudo docker ps-a, and don't forget the q. So all containers have been removed. Now let's remove the images. Image rmi dollar open parenthesis sudo docker images dash q. So now we've removed all previous images. Let me see now sudo docker network list. We only have the 3 standard networks, so we do not have to remove anyone. And sudo docker volume, also we won't have any volume created. Let's also remove this mysql-data here. Remove sudo remove -rd mysql data. Okay, now we have everything empty. So now we are able to test through Docker Compose the running of our Docker Compose YAML file. And now for running our YAML file by using Docker Compose, we only have to create a text file. So sudo gedit docker -compose.yml and copy all the content from this file at our source, the springboot midnap or MIDI management repository. Only copy the content of that YAML file to our local YAML file. Save it. Here we have the Docker Compose YAML file. Let's just check if the content has been saved actually. So sudo cat docker compose.yml. So here it is, all the content we need for fetching those 2 dockerhub images, creating the respective 2 containers, connecting those 2 containers, and run our Spring Boot container connected to the MySQL container. So after creating the YAML file and setting all the content inside, what you have to do, sudo docker compose without the dash, sudo docker compose app. So we gotta be at the directory we want to execute the application. In this case, we are executing it from inside the temp directory here at my home folder, and we simply call sudo docker compose app, and it will search for any YAML file we have here and run. So let's hit enter, and then it's taking all this content here inside the YAML file, and it's creating in the right sequence the 2 containers and starting them the way we set or configured inside the YAML file. So pay attention that it's first checking that the MySQL container has been actually started, and only then it starts the Spring Boot container, because the Spring Boot container gotta connect with an already started DBMS or MySQL database. So the Spring Boot container here has succeeded both in starting and connecting to the previously created and started MySQL container. We could have, for example, used here the sudo docker compose app-g, and then we wouldn't have all this execution attached to our TTY or to our console. But as we have already run it, we can now simply go to our browser and check localhost column 8080, and the application should be up and running and accessible through this 8080 port from our browser. So here it is, the same application running through Docker Compose and the YAML file with all the settings for the 2 services we needed for starting these 2 containers and connecting them both into one a single system here running the application. So also we can check here if the database is working by adding a new person. Click in add. Here is the fourth person. And when we have, for example, the containers running here, we can simply stop Docker Compose or stop the containers from Docker Compose by clicking Ctrl C. So Docker Compose has stopped both containers. If we check here sudo docker ps-a, none of them is up anymore. So if we try anything here at the application, it won't work because the application is down. And how can we start it again? Sudo docker compose app, and now let's use the -g and enter. So it will start those two containers again with the same configurations found inside a YAML file. So it first starts the MySQL container. When it's in the healthy status, it then starts the Spring Boot container. In both cases, as we set here the -g in the detached mode. How we know it's running? Let's go to the localhost :8080 and the application should be running again. And for checking if the persistency is actually running, simply go here, for example, and see that the fourth person that we have added before is still here, saved at our MySQL database external volume outside the MySQL container. So it's still here. So both the connection between the Spring Boot container and the MySQL container is working, as well as the communication between the Spring Boot application and the MySQL database at the mapped volumes we've set. So everything worked pretty fine. And now if we test here sudo docker ps-a, the two containers are still running. How can we stop them? We could use the docker container stop, but as we're testing the docker compose, we can use sudo docker compose down command. So as the docker compose app starts all the related containers for those services set at the YAML file, the docker compose down will also close or shut down all the containers related to that two services that we have set inside the YAML file. So sudo docker compose down, it simply stops and removes not only, observe here, not only the two containers, the Midinap Spring Boot container and the Midinap MySQL container, but pay attention here, the user-defined bridge network it had created for running those two containers on. So it also creates by default a user-defined bridge network and runs those containers on that same user-defined bridge network. So with this lecture, we conclude the official content of our course. And if you have any doubts at all about any of these lectures, since the first one to this last one, please let me know. You can contact me through Udemy, through my LinkedIn, through my email, and all of these will be available at my instructor page. And I'll make my best to answer all the questions that have anything to do with the content we presented in this course. So I'll probably add more content later. So see you in the next lecture. God bless you all. Bye bye.